to write a mathematical expression in a different form to make the expression easier to understand or an equation easier to solve. So that's going to be the purpose behind what we do today. Okay? And it's interesting because in my AP Calculus class, we use this. We're finding something called a derivative. And so when we have a cube root or a square root, we have to rewrite them into a power form. So it does get used, and I do hope that you go to pre-calc next year and then take AP Calculus. We've done some super fun things today. I gave them charms blow pops, and we talked about something called the chain rule. I gave them juice boxes and animal cookies when we talked, and I read them a story. The monster at the end of the book, and I have a little Grover. So AP Calculus is a fabulous class, so I hope you can get there. All right, recall that in an exponential expression such as 4 cubed, the number 4 is called the base, and 3 is called the exponent. You would say that's 4 raised to the power of 3. If the exponent is positive, you can write it in expanded form. 4 cubed would be 4 times 4 times 4, and that would be 64. So what I want you to do in example 1, I'm going to do letter A, then I'm going to ask you to do this with B and C and make a generalization as to what you think is happening. So 2 cubed is 2 times 2 times 2. 2 to the 4th is 2 times 2 times 2 times 2. So I can now go back to my definition of an exponent, and that's 2 to the 7th power. Okay, that is 2 to the 7th power. Now, for part B and C, I would like you to expand and then write it in what we call exponential form, the base to an exponent. All right, talk at your tables. Have somebody read off their answer for B and C, and then try to generalize together as a table. Yeah, sorry, I fixed it. There we go. Does yours say the 4th power there too? All right, so if you put these in expanded form, you should have got next to the 11 and x, or 10 to the 6th. So what's the generalization? What can you say when you take a product with the same base? What's happening? Yeah. Good job. You're just going to add the exponent. So we write it like this. If I take a to the m times a to the n, so you have to have the same base, the shortcut is you can add the exponents. All right, in example 2, we want to write the numerator and the denominator in expanded form. So 4 to the 5th power means 4 times 4 times 4 times 4 times 4 over 4 squared. So you're going to take the numerator and denominator and put it in expanded form. Then you want to simplify. I can cross out 2 sets of 4s in the top and the bottom. So that would be 4 cubed. Now, I want you to expand letter B, but don't do D because that one's obnoxious. But use your shortcut that you think you have in part C without writing all of it out. But in B, write it out. All right, in letter B, did you get x squared? And in C, did you get 0.94 to the 10th? So what's the generalization? What can we say is happening, Lilia? You subtract the exponents. You do need to make sure that the bases are the same. So we would say a to the m over a to the n equals a to the m minus n. All right, in example 3, if I have 2 cubed divided by 2 to the 4th, so I can cross out, and do you notice you get 1 over 2? You actually get 1 over 2. The 2's in the bottom. So let's circle back to this one up here. Wouldn't 3 minus 4 be negative 1? And so we've sort of been using this one already, and that's okay. So letter B, 4 to the 5th. I would do 4 times 4 times 4 times 4 times 4. 4 to the 7th. Cross out the common factors. So that leaves us with 1 over 4 squared. But if you subtracted, isn't that 4 to the negative 2? So this is like verifying what we've been using with our exponential functions. All right, let's try to do letter C without expanding. Okay, let's try letter C without expanding. So this would be x to what power if I just subtract them? Negative 5. And then in math, we don't leave negative exponents. That's like a fraction that you don't reduce. So don't leave negative exponents in your final answer. So let's generalize the results. You are going to do a to the m over a to the n is a to the m minus n. And then a to the negative n is 1 over a to the n power. All right, we have 2 more exponent properties that we're going to develop. So if we move along to example 4, it says expand each expression. So if I have 2 cubed to the 4th, that means 2 cubed times 2 cubed times 2 cubed times 2 cubed. So I can now use the first exponent property, that I can add those exponents. So 3 plus 3 plus 3 plus 3, that's 12. All right, let's do that in letter B. 3 squared to the 5th means 3 squared times 3 squared times 3 squared times 3 squared. All right, now we're going to use the exponent property in number 1. and you would add those exponents. 2 plus 2 plus 2 plus 2 plus 2 would be 3 to what power? 10, right? Then in letter C, if I have x to the 4th cubed, when you cube something, that means take it times itself 3 times. So that's x to the 4th times x to the 4th times x to the 4th. So that's x to what power? 12. So here's the generalization. If you take a to some power and you raise that whole quantity to a power, what did we do to the powers? Yeah, you're going to multiply the exponent. So that's a to the m times n. All right, example 5. It says use properties to show that 5 to the 0 is 1. So like we've been talking about that, anything to the 0 power is 1. But you shouldn't just believe me, you should be able to verify it, okay? So if there's things that I'm telling you and you're like, I don't understand the why, ask, okay? Usually I have said why, and we just need to hear it again, and that's okay. So watch this. What if I have 5 to the 3rd over 5 to the 3rd? Well, what do you know when you take a number and divide by itself? It's 1, right? Okay, so over here to the left, I'm going to call that 1 because it is 1. That's like 125 divided by 125 is 1. Now over here, if I also use my quotient rule where I can subtract the powers, isn't that 5 to the 0 power? That's why anything to the 0 power is 1. And when I say anything, it technically isn't anything. It's anything except 0, because 0 to the 0 actually isn't 1, okay? So generalizing the results, a to the 0 power is 1. So now what I did is in this blue box, I put all the properties together. The only two I didn't do with you were the power of a power, and let me show you an example of this one. If I had 2x to the 5th power, that would be 2 to the 5th, x to the 5th. That's what that one means. The other one I didn't do an example of is this one. What if I give you 3 over y to the 2nd power? You take the numerator to that power and the denominator to the power, as long as it's just a fraction, not a sum or a difference, because then that doesn't work. All right, in the previous section, you learned to solve equations that have a variable in the exponent by using a calculator to try various values of x. The properties of exponents allow you to solve these types of equations algebraically. One special case is when you can rewrite both sides of the equation with a common base. So, let's look at example 6. It says solve each equation by writing both sides using a common base. So, what I need you to do is I need you to look at, well, maybe we make a little table here, just a few of these, okay? So if I have a base of 2, 3, 4, and let's say 5, and I'll call that base B. If I square them, that's 4, 9, 16, and 25. If I cube it, 2 cubed is 2 times 2 is 4 times 2 is 8. 3 cubed is 3 times 3 is 9 times 3 is 27. 4 cubed is 4 times 4 times 4, which is 64. 5 cubed is 125. Let's go ahead and do the 4th powers. We'll call it a day there. So 2 cubed is, or 2 to the 4th power. 2 times 2 times 2 times 2 is 16. This one's 81, 256, and 625. There is something called number sense. Number sense is knowing how numbers add and subtract, how numbers multiply together, and how numbers divide. Okay, so knowing these is helpful. All right, having done that, let's look at 8 and 4. If you look at any row of the table, do you see a common base that 4 and 8 have? 2. Okay, so watch what we're going to do. I'm going to rewrite 8 as 2 cubed. And I'm going to rewrite 4 as 2 squared. So let me go over this again. When I have 8 to the x equals 4, right now, I don't know how to solve that. Okay, that type of equation. When the variable's in the exponent, you can't multiply or divide both sides by something and get the exponent down. We're going to learn later in the chapter, there is a math tool that we're going to put in our tool belt that will help us. But for now, what I know is if I can create common bases, and the bases are the same, then the exponents have to be equal. Okay, so what I know is 8 is 2 cubed, and I know 4 is 2 squared. All right, well now we're going to use the power of a power property. Remember this one. If I have 2 cubed to the x power, that's 2 to the 3x. I'm using this exponent property. Now, I am not canceling the bases. And I want to say this multiple times because I have students say, oh, you cancel the base? No, 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 no. There's no such mathematics that allows us to cancel a base. But what I do know is in order for 2 to the 3x to equal 2 to the second, when you have a common base, their exponents must be equal. I'm not canceling the bases. But what I am saying is in order for that equation to be true, the exponents must be equal. So 3x equals 2, divide by 3, and x is 2/3. All right, so the hardest part is coming up with how to rewrite them with the common base. So I want to pause a moment, and I want to let you try letter B. How can you rewrite 27, and how can you rewrite 81 so that they have the same base? Like some number to an exponent gives you 27, that same base to another exponent gives you 81. Look at the chart. Well, we're going to have to look back at your exponent properties. That's a great question. What can we do when it's 1 over? All right, 27. How can you rewrite 27? Lilia? Okay, that's 3 to the third. Okay, then 81 is 3 to what power? Okay, well first I'm going to make it 1 over 3 to the fourth, and then you've done a beautiful job there. So 3 cubed to the x is 3 to the 3x, and then you're absolutely correct. That negative exponent is going to help me make it 1 over 3 to the fourth. So anytime you have fractions with exponents, that usually includes a negative exponent. So now the bases are equal, so now the exponents must be equal. So x would be negative 4/3. All right, letter C. I want to do this one with you because this one's really a doozy of a problem. 49 is 7 squared. 9 is 3 squared. Now, do you see the negative exponent over here? That this is 3/7 to the negative 3/2. Well, guess what I can do? When I have a fraction to a negative exponent, you can actually flip the fraction and make it a positive exponent. Let me say that again. It's tricky. When you have a fraction to a negative exponent, you can flip the fraction and make the exponent positive. All right, now on the left side, I'm taking 7 squared to the x, and I'm taking 3 squared to the x. Or you know what, I think I don't want to go that route. Sorry, so I'm like, yeah, that's not working for me. How about this? Do you see that that would be 7/3 squared? Yeah, that's a better route. And do you notice, like I started writing that and went, yuck? Guess what? That happens and it's okay. Then you back it up and go, wait, that's not the direction I want to go. Okay? So 7 and 3 are both squared, so I can pull the square out. Then that's 7/3 to the 2x. There we go. That's working for me now. All right, let me talk you through that again. That's a little tricky. So do you see 7 squared and 3 squared? They're both, 7 and 3 are both squared. So I can take 7/3 and take it to the second power. Because that's true, right? That's one of those exponent properties. Then I have a power to a power, so I multiply. Now I got the bases the same. So those of you that like puzzles, like I love doing puzzles and I like mysteries, I like forensic stuff, this floats my boat. This is to me fun because you're trying to figure out how do I get the bases to be the same. And that's the people who like math, they like the mystery and the solving and trying to figure it out. It's pretty cool. All right, so now I get the bases the same. So 2x equals 3/2. Now, if I divide by 2, I have a fraction divided by 2, which is yucky. What's another way to divide by 2? Yeah, let's do this. Couldn't you multiply by the reciprocal instead? So then, now, it's okay to take on the calculator 3/2 divided by 2. That's okay. It'll give you a decimal. But we can also do it like this.